Welcome to Physics, Current Electricity, Session 10 and 11. Aim of today's session is to study about Wheatstone Bridge network and the electrical instruments of measurement. First, let us study about Wheatstone Bridge and condition of balance. This is an arrangement of four resistances, out of which one is PQRS, and a galvanometer is connected to the unknown resistances. So this arrangement of resistances we call as Wheatstone Bridge network. The Wheatstone Bridge is shown in the figure. It has four resistances P, Q, R and S. G is galvanometer. Point A and C are connected across the source of EMF V, and point B and D are connected with the galvanometer with resistance G as shown in this figure. Now current I starts flowing in the network and the current will subdivide. Current I from the cell divides I1 and I2 at junction A, and I3 and IG, G is the current through galvanometer, at junction B. This IG combines with I2 to give current I4. At junction D, I2 and IG current combine to give I4. At junction C, I3 and I4 combine to give back the current I. So we have taken this current as I1, this current as I2, this current as I3, this IG comes here, this current is I4, and I4 and I3 combines to give back the current I. Now, using junction rule, at junction A, we can write I is equal to I1 plus I2. At junction B, I1 is equal to I3 plus IG. At junction D, IG plus I2 to give the current called I4. At junction C, I3 plus I4 gives the current I. Now we can use loop rule. Loop 1 we can take it as A, B, D back to A. A, B, D back to A. So what we are going to get? Minus I1P minus IgG plus I2 into R is equal to 0. Similarly, we can apply second loop rule to the bigger junction A, B, C, D back to A. We can start minus I1P minus I3Q plus I4S plus I2R is equal to 0. Now, the resistance PQRS are variable. So, by adjusting the resistance PQRS, we can make the potential of point B and potential of point D to be same. The Wheatstone bridge is said to be balanced when no current is flowing through the galvanometer. The Wheatstone bridge is said to be balanced when no current flows in galvanometer. So, potential of B is equal to potential of D. Since Ig is equal to 0, no current flows through galvanometer means the current through the galvanometer is 0. In this arm, the current is 0. That means potential of point B and potential of point D is equal. When potential of point B and potential of point D is 0, current in the galvanometer is equal to 0. Ig is equal to 0. Substituting Ig 0 in this junction rule formulas, we get I is equal to I1 plus I2. Here we are going to get I1 is equal to I3 because Ig is 0. And this equation we get it I2 is equal to I4. What does it mean? I1 is equal to I3, I2 is equal to I4. Since Ig is equal to 0, that means the same current flows through arm A, B and BC. And same current flows through arm AD and DC. Substituting Ig is equal to 0 and I1 is equal to I3 and I2 is equal to I4 in these two equations. Here Ig0 gives you minus I1P plus I2R is equal to 0. Here minus I1P minus I3. I3 I can replace by I1. I1Q plus I4S plus I4 into R, or I4 I can replace by I2. I2 into S plus I2 into R is equal to 0. So let us rewrite these two equations substituting these values. So minus I1P plus I2 into R is equal to 0. This is one equation substituting Ig is equal to 0. And second equation minus I1P minus I1Q plus you can write I2 into S plus I2 into R is equal to 0. Replacing I3 as I1 and I4 as I2. So we can rewrite this equation as the first equation as I1P is equal to I2R, and this equation as I1 into P plus Q is equal to I2 into S plus R. Now dividing this equation by this equation, we get it P by Q by P is equal to S plus R by R, or 1 plus Q by P is equal to S by R plus 1, or finally P by Q is equal to R by S. If the ratio of resistance P and Q is equal to ratio of resistance R and S, then the bridge is said to be balanced. This is the condition of balance. And current through the galvanometer is 0. Current through galvanometer is 0 and P by Q is equal to R by S. That means when resistance P by Q is equal to ratio of resistance R by S, then the current through galvanometer becomes equal to 0 and potential of point D and B will be equal. Then it is called a balanced Wheatstone bridge condition. Now when Wheatstone bridge condition is satisfied, then remember P and Q resistance will come in series, R and S resistance will come into series. Or if we can join this point B and D because they are at the same potential, P and R are said to be in parallel, Q and S are said to be in parallel. So by adding both, we can calculate the equivalent resistance. So if a network is given, we try to see whether it is satisfying Wheatstone bridge condition or not, such that P by Q is equal to R by S. And if the Wheatstone bridge condition is satisfied, then immediately we can take P and R in parallel, Q and S in parallel, and add them in series. So Wheatstone bridge condition, potential of point B is equal to potential of point D, current through the galvanometer is 0, and P by Q is equal to R by S. Different forms of Wheatstone bridge. So see, across A and B we are connected a battery, so current is going to flow I, and opposite diagonals the galvanometer is connected. This is the galvanometer. Current in this arm is equal to 0, so we can write this one as P by Q is equal to R by S. P by Q is equal to R by S. Now if this network is seen, pull this arm A over here. So when you pull this arm A over here, this is the arm which you are calling it A, then this resistance looks like this. This resistance looks like this. Now see, these are the resistance P, this resistance is Q, and this resistance R and S. So when P and R and Q and S are balanced, there won't be any current flowing through this arm. This Ig will be equal to 0. It converts into Wheatstone bridge. Here also, this is the galvanometric arm. This current I splits up into two parts, I1 and I2. And this current in this circuit will be equal to 0. This current will be equal to I3 and I4. And these two currents will be same to give back the current I. When the current flowing in this arm Ig is equal to 0, P and R in series, Q and S in series, those two circuits are in parallel. This also converts into Wheatstone bridge. So there are different forms of Wheatstone bridge satisfying the condition P by Q should be equal to R by S.